Find the area of the region bounded by the curve y equals sine of x and y equals cosine of x from 0 to pi over 2. First, we find the intersection. We can do this algebraically, or we can sketch the graph of the two basic functions. The graph of y equals cosine of x go through the point x equals 0, y equals 1, and when x equals pi over 2, y equals 0. When x equals pi over 4, y is root 2 over 2. And so we have the graph of y equals cosine of x. The graph of y equals sine of x goes through the point 0, 0, and when x equals pi over 2, y equals 1. And so we have another graph. The red graph is the graph of y equals sine of x, and the blue graph is the graph of y equals cosine of x. And we see that the two graphs intersect at the point x equals 0, y equals pi over 4. From 0 to pi over 2, we would need to stop at pi over 4. The intersection of sine of x and cosine of x between 0 and pi over 2 is pi over 4. Therefore, the area is the area of the two regions separated by pi over 4. We will end up with two definite integrals, one from 0 to pi over 4, another one from pi over 4 to pi over 2. In each of these integrals, we still need to set up the upper curve minus the lower curve. Between 0 and pi over 4, the upper curve is cosine of x, and between pi over 4 and pi over 2, the upper curve is sine of x. The first area, the antiderivative is sine of x plus cosine of x, evaluated from 0 to pi over 4. And this is sine of pi over 4 plus cosine of pi over 4 minus sine of 0 plus cosine of 0. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is also root 2 over 2. Sine of 0 is 0, and cosine of 0 is 1. This first area is therefore root 2 minus 1. The second area should be root 2 minus 1 also, because of symmetry. And so the total area is 2, the square root of 2 minus 1, or 2 root 2 minus 2. In each of these cases, it will definitely help if we graph the curves on the same coordinate axis. Notice that if we didn't see the symmetry, the second area can be evaluated using the fundamental theorem of calculus. The antiderivative of sine of x is minus cosine of x, and the antiderivative of cosine is sine of x, evaluated from pi over 4 to pi over 2. This is minus cosine of pi over 2 minus sine of pi over 2 minus the quantity negative cosine of pi over 4 minus sine of pi over 4. Cosine of pi over 2 is 0, sine of pi over 2 is 1, cosine of pi over 4 is root 2 over 2, and sine of pi over 4 is root 2 over 2. Simplifying this, we have 0 minus 1 minus the quantity negative root 2 over 2 minus root 2 over 2, which is negative 1 plus 2 root 2 over 2, or the square root of 2 minus 1, which is the exact area as the first integral.